Hey guys, as promised, I'm going to do a couple problems from your review worksheet on this video tonight, starting with number 15. So in 15, they're giving you guys a bunch of information here, and the first thing I notice is that both of these numbers are 8. Obviously that means that they're the same thing, which means that these segments are congruent. Alright, so it's one of the theorems that we talked about very briefly. But what this is telling me is that both segments, MN, which is this one right here, and PQ, those are both equidistant from the center. I know that because the distance from that first MN green segment to the center is 8, and same with this second one. They're both 8 units from the center, and that tells me that those two are going to be congruent. So this whole segment, MN, is going to be congruent to the whole segment PQ. The second thing I'm noticing is that we have two perpendicular symbols. So this isn't going to look it, but what that's going to tell me here is that since this segment is going through the center and it's perpendicular to the chord, through the center, perpendicular to the chord, automatically tells me that it's going to bisect the chord. And again, I said it's not going to look like it. In this picture, it's not drawn to scale, but it is true. If it goes through the center, perpendicular to the chord, then it's bisecting the chord. So what does that mean in terms of segment YQ and PQ? I'm looking for this segment YQ. I'm also looking for the length of PQ. Well, for YQ, what I'm going to notice is that this segment YQ is going to be the same as PY. And I also know that MX is 12. If MX is 12, that means that XN is also 12 because we just concluded that these are going to be congruent. Okay, which means this whole segment is 24, 12 plus 12. What does that mean over here for YQ and PY? It means that this whole segment is also 24. We established that the whole chord is congruent to the whole chord since they're equidistant from the center, and that means that each of these pieces is going to be 12. In conclusion, we have our final answer, YQ, okay, is going to be, which is just this segment right here, is 12. And PQ is 24. The theorems that we used here, you guys, are that if two chords are equidistant from the center, I'm going to abbreviate that, equidist from the center, then they are congruent. I'm using my finger right now to write, so excuse the handwriting. That's the moral of the story. And also, the second one was if the segment is perpendicular to the chord and it goes through the center, it's going to bisect the chord. Moving on to the next one. Here we have number 20. Number 20 is a good problem. We're given that CE is 2. Okay, we're also given that PD is 5. Find AB. Love this. I'm looking for this whole chord. Okay, guys, first thing I'm noticing, 5 is a radius. Okay. So since 5 is a radius, that means any radius I draw in can also be a length of 5. So I'm going to connect P to B. Okay, that's also a radius. It starts at the center, it goes to B on the edge of the circle. So that is also a radius of length 5. Second thing I'm noticing is that they give me this little piece as 2, but that yellow segment is also a radius. So that whole yellow segment is going to be 5 because it's also a radius. I know that's hard to see. Sorry about that. That yellow segment's kind of hard to see, but it's also a radius. I'm going to try to zoom in here. There we go. But what I can see is that since this guy is 2, I know that this piece right here is going to be 3. Now, if you look carefully, you can see that we have a right triangle with 2 sides, 3 and 5. This is a 3, 4, 5 triangle. I could use Pythagorean theorem, but I could also notice that it is a triple, which means that this segment, EB, is 4. And that's going to tell me that this segment, AE, is also 4, which means AB is going to be 8 units long. Alrighty, let's go on. Number 21 is asking us to find segment AB. That's our goal. Okay, it gives me that this segment is 4. Let's try that again. This segment right here, AY, is 4. Alright, so first thing I'm noticing here is that these two angles are congruent. They also add up to a straight line, because APB is a straight line. So they're almost mismarked. We are going to remark these as 2 right angles, because if they're congruent and they're going to add up to 180, then those are each 90. So they're right angles. Alright, so now I have 2 right triangles. The second thing that I'm really seeing here is the fact that PA is a radius and PB is a radius. So those are going to be congruent since they're both radii. The other interesting thing is that PY is also a radius. So if I look and I just zoom in on one of these triangles, let's do that. What I have here is a right triangle with 2 congruent sides. This is what we like to call a 45, 45, 90 triangle. That's right, people. We got a 45, 45, 90 here. And that hypotenuse is 4. So if you guys remember, we have A root 2. So what I can do is I can say 4 is equal to A root 2. I can divide both sides by root 2 to get A by itself. Now, 4 divided by root 2. 4 divided by 2 is 2. Tack on your root 2. That's our trick. So that means A is 2 root 2. What does that tell me for this problem? It means that PA is 2 root 2. It means that PB is 2 root 2. And if I just combine these, 2 root 2 plus 2 root 2, just combine your like terms. 2 and 2 is 4. Keep your root 2, and that's your answer. Cray cray. I like that one. Alright guys, one more problem to do. And it's a big one. This is a big problem. So we're going to try to get through this step by step. I'm going to go a little bit out of order. I'm going to start with the area of the circle. Alright, I'm given a circle. I have a radius of 24. Guys, area of a circle is pi r squared. So I'm going to have pi times 24 squared. 24 squared is 576. Keep the pi there. 576 pi is your area. Area of the circle. Alright, so that's what the area of the circle is, and we're going to use that in a couple other parts of this. So let's go ahead. We started with area of the circle. Let's go to area of the sector. Guys, remember, the sector is this whole piece of pizza. So this whole thing is the area of the sector. And I'm going to erase that so we can still see that area of a segment once we go for that. Okay? But that's the area of the sector. So, let's zoom in over here. Area of the sector, we have, it looked like this. We knew that this was a right angle, okay? Our formula for area of a sector is going to be angle over 360 times the area of the circle. I use the area of the circle because I'm taking a piece of the area. The angle over 360, guys, the central angle here is 90 degrees. So 90 over 360. There's more than one way to do this. You might notice that that's a fourth of the circle. We also found that the area of the circle, we found it over here, is 576 pi. So if you put that in your calculator, you guys, again, you could reduce 90 over 360 to 1/4. But you're going to do 90 divided by 360. You're going to get a decimal, which should be 0.25, times 576. Do not put in the pi yet. Okay, when you do that, you should get 144. Then tack on the pi. So the area of the sector is 144 pi. Let's stick with the theme of area right now and go to the highlighted segment. So the highlighted segment is the shaded part of the circle. So it's the part that's gray here. All right, and to do this, you guys, and this is what we learned last week, what you want to do every time is take the area of the sector minus the area of the triangle. Okay. Well, the area of the sector, that's angle over 360 times the area. We already found that. We found that it's 144 pi. That's not just coming out of nowhere, guys. We got that over here. Okay, so you would have to do that work if this was a completely separate problem. But now I want to find the area of the triangle. The area of the triangle is 1/2 base times height. If you look at your triangle, and I want you guys to try to like rotate the triangle. So if you move your head and you look at the triangle this way, I think it's a lot easier to see which one's the base and which one's the height. All radii are congruent, so this radius, RO, is also 24. And I hope you guys would agree with me when I say that this is my base, RO, and my height is RA. Okay, so my base and my height are actually both 24. We're going to rotate that back. My base and my height are both 24. Okay, in your calculator you can do 0.5 times 24 times 24. When you do that, you should get 288. Okay, your final answer is the area of the sector minus the area of the triangle. Final answer, 144 pi minus 288. Just leave it like that. That's an exact answer. So that's the area of the highlighted segment. Last but not least, guys, this is an arc length problem. It's asking me to find the length of OA, which is an arc. To do that, and this is what it's a little separate from what we've been doing, okay? It's a piece of the circumference, so it's angle over 360. For arc length, we use the circumference. Circumference is 2 pi r. So here, 2 times 24 is 48. So I get 48 pi. And angle over 360 is 90 over 360. So then, So then my final answer, when I plug that into my calculator, should be 12 pi. Okay, and you guys can make sure that you take a look at that problem again, and that's it. Okay, so please study it up tonight. Hopefully these problems helped you guys a little bit. If you have any more questions, come on in early, shoot me an email, come see me during second or third. All those options are good ones. Good luck tonight, guys. See ya tomorrow.